Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In a previous video, we have understand the compound called as the photostabilizer, which are generally used to protect our polymer from the photodegradation, which is mainly caused by the ultraviolet rays coming out of the suns. If you have missed that video, you can find it in the I button over here. Now, having said that, let's just move to the properties, or we can say desired properties of the photostabilizer. As you can see here, the first property of the photostabilizer is the non-staining, as it should not be create any stain on the polymer, right? As we are using this photostabilizer on the polymer which are generally having bright colors. So it would be only failure of the photostabilizer if it creates stain on the polymer, right? Stain means it will create one black kind of a dots on the polymer surface. So our photostabilizer should not create any staining on the polymer. Then the second property of the photostabilizer is it should be non-toxic, as our polymer should be non-toxic, which means on the application of the heat there should not be generation of the any toxic gases or toxic chemical that can harmful for the environment. And at the last we have last property of the stabilizer as the chemically inert. So our photostabilizer should be chemically inert. It should not be reactive with any another material such as air, or we can say oxygen present in the air, right? It should not be reactive with the oxygen, or ultimately it will lead to the oxidative reduction, oxidative degradation of the polymer. So this was all the properties that can be asked in a 2 or 3 marks question. Now after understanding this, let's just move to the next type of the degradation, and that is biodegradation of the polymer. Well, this biodegradation is not only about the reduction in the molecular weight of the polymer or its physical change of the polymer, right? It is more than just a reduction in the molecular weight of the polymer. It is a biochemical process which take place on the polymer by the different living organisms. As you can see here on the screen that biodegradation of the polymer is much more than the molecular weight loss, disintegration or the growth of microorganisms. So it is much more than the only reduction in the molecular weight. It is basically a biological process of the polymer degradation. So this biological process of the degradation is take place on the polymer by the different living organisms. As you can see here, before discussing about the biodegradation of the polymer, we need to understand what are the factors that are being affecting, or what are the factors that being responsible for the degradation of the polymer. The first factor, as you can see here, is the mode of disposal and the surrounding conditions, which means what is the actual mode of the disposal of your polymer. Your polymer can be disposed in a many ways. As you can see here, if your polymer is present in the sewage treatment, such like polyethylene and some bags are always found in the sewage line of the cities, right? Or there is an aerobic or anaerobic treatment of the polymer. So these are the basic condition, or we can say surrounding conditions for the polymer degradation, which affect the biodegradation of the polymer. Then we have rate of degradation. So our polymer should have higher rate of the biodegradation, which means your polymer should be easily biodegradable, right? As we have to focus on the polymers which can be easily biodegradable. So your rate of biodegradation should be high, because your polymer will easily degrade once it has been used or its service life has been over. Then the next factor which affect the polymer degradation is the end product and the intermediate product. There are different end products such as carbon dioxide, oxygen, even water molecules that have been generated when your polymer biodegrades. Or even there is the possibility that the polymer disintegrated or degrade into the biomass, which can also be useful in a further applications. So these are the different factors that affect the biodegradation of the polymer. Now, as you can see here, the biological attack includes alternation of the polymer system by fungi, bacteria and large species such as insects and animals. So these are the different living organisms which are being responsible for the biodegradation of the polymer, such as fungi, bacteria, the large species such as insects and animals. They are generally degrade our polymers, right? And most naturally occurring polymer are biodegradable in their native state. So if you recall our first introduction lecture, we have said there are natural polymer and synthetic polymers. So natural polymers are more prone, or we can say they are generally more towards the biodegradation process, such as cellulose, proteins, glucose. They are biodegradable, right? While on the other hand, synthetic materials, or we can say synthetic polymers, are not that much affected by the biodegradation. Then you can see here modified natural materials such as acetyl cellulose or sulfur cross-linked rubber are quite resistive. So these are the synthetic, or we can say semi-synthetic materials that do not undergo the biodegradation process. So even some polymers such as polystyrene or polyamides or even polyurethanes are some kind of the polymer which can undergo the biodegradation process under specific conditions, even though they are semi-synthetic or synthetic polymers, right? So synthetic polymers can also be undergo the biodegradation process in the presence of the oxygen. Now, as you can see here, in this degradation, the microorganisms are using the material as the source of nutrient, with enzymes generated by the microorganism which act as the catalyst. So basically this biodegradation of the polymer is a chemical reaction in which the microorganisms are the source of these reactions, and enzyme generated in this chemical reaction is act as the catalyst. Then in the earlys of 1970s, people concerned for the problem of the waste disposal that lead to the development of the polymer that can be disintegrated, or we can say biodegraded. So now we are in a situation where we cannot afford much of the plastic, or we can say polyethylene, right? So we have to always look for the alternative, and that alternative can be these biodegradable polymers. So our problem of the waste disposal has led us to the development of the such polymers which can easily biodegrade. However, with the few application of such biodegradable polymers are there, this is the limited content, right? So we have to look for the further more development of such biodegradable polymers. Now, having said that, let's just move to the next type of the degradation process. As you can see here on the screen, that the next is the degradation by the high energy waves, or we can say high energy radiation. We have already understand one type of the radiation, that is the ultraviolet radiation. But there are more rays than the ultraviolet rays, such as gamma rays, X-rays, beta rays, and even your alpha rays, right? This all the radiation can also affect our polymer by significantly. As you can see here on the screen, that it is the degradation which is being caused by the gamma rays, X-rays, alpha rays, and beta rays, right? Energy of their rays are very massive, and they can be affect our polymer to large extent. Here the beta rays is nothing but your fast moving electrons, and the alpha rays is again nothing but your fast moving helium nuclei. So as we can see here, these are the very high intensity radiation, or we can say high intensity wave. The degradation offered, or the degradation done by such waves, is again very massive. This degradation can be done in a two ways. The first one is the seasonal, is basically nothing but it represents the reduction, or you can say lowering the molecular weight of the polymer. So it is very much known that when our polymer degrades, it breaks, right? The long chain of the polymer breaks. So it is but obvious that its molecular weight will reduce. So seasoning means the breaking, where the breaking of the polymer take place and molecular weight reduces. While the second type of the high energy radiation, or you can say high energy degradation, is the cross linkage. As you can see here in this particular disintegration, or you can say degradation, cross link between two polymers is being formed. right? And this ultimately leads us to the buildup of the network of polymer. And as you can see here, it will ultimately increase the molecular weight of the polymer. Because the network of the polymer is being created, hence its molecular weight is of course going to increase, right? We will understand both the thing with the example, and it will clear all the idea about the degradation of the polymer by high energy radiations. Let's just understand first this cross-link degradation by the high intensity energies. As you can see here, there are some of the examples which can undergo this type of the degradation process, such as polybutadiene, then we have polytetrafluoroethylene, then we have ethylene molecules, then we have cellulose, polyalpha methylstyrene are some of the examples that can undergo the high energy radiation, or you can say high energy waves degradation in the sizzling effect, right? Then the polyethylene, polypropylene, polyamide, and even polyacrylides are some of the examples that can be degraded by mean of the cross linkage or the application of the high energy, or you can say high energy radiation. So as you can see here on the screen, that when the polymer are being exposed to the radiation coming out of the sun and they absorb high energy radiation, they will decompose or they will produce molecule or gases such as H2, CH2, carbon monoxide, methane, and ammonia type of the compound. So let's understand first this linkage type of the degradation. This particular image explains the cross linkage type of the high energy radiation, in which you can see here I have taken the example of the polypropylene, right? And let me just take a pen here. So this particular polymer is the polypropylene, which I have represented by these waves. And these are the hydrogen atoms which are being connected on the polypropylene molecules, right? So when we apply high energy radiation, this hydrogen bond will be break up and the free radical will be generated on this particular carbon. As you can see here, I have applied high energy radiation, and now this hydrogen bond has been broken up and they are generating free radical like this. 1, 2, here the second one, here we have third, fourth, fifth, and sixth. So as you can see, we have generated 6 hydrogen atoms. So it will ultimately form 3 hydrogen molecules like this, 3H2, right? This is the first one hydrogen molecule, second and third hydrogen, right? So there will be 3 hydrogen will be liberated off, as you can see here, on the application of the high energy radiation. Now next what will happen is these 2 free radical will make a bond with each other and they will connect it with the double bond like this, right? So this carbon will be linked with both of the carbons since they have free radicals. So we will have structure like this. So this is the polyethylene which has degraded by the high radiation energy. Now let's understand one more example of this sizzling process. As you can see here, polyisobutyl is subjected to high energy radiation and ultimately it forms methane and hydrogen bond. So let's understand how this type of the degradation take place. Let me just take a pen here one more time. So you can see here, this is the molecule of the polyisobutyl, right? This is the polyisobutyl which has one alpha carbon which is being connected with the CH3, and here we have CH3 as well, CH2 as well. And this chain continue to follow, and again at this end it is also continue to follow, right? So on the application of the high energy radiation, as you can see here, this particular monomer will degrade and this particular carbon bond will break out. You can see here, this carbon-carbon bond will break out because of the high energy radiation, and this bond will be equally shared by the both nearby carbons, right? And free radical will be generated. As you can see here, this carbon-carbon bond has been broken up, hence CH3 from this particular atom has now liberated off. You can see here we have written plus CH3, which means CH3 has been liberated off because this particular carbon-carbon bond has been broken up. And again from here one hydrogen will also be broken up. So as you can see here, this hydrogen from this particular carbon is also being liberated off like this. Hence now free radical is being generated on this carbon and on this carbon as well. and they will be linked with one more bond. As you can see here, this is the double bond. So they are being connected with the double bond like this, right? So what will happen with this CH3 and hydrogen group? Well, they will linked with each other since they also have free radical within, and ultimately they will form methane like this. So this is the degradation of the polymer under the seasoning process by means of the high radiation energies. These questions are again very important to explain polymer degradation by the high energy radiation. And this concludes the chapter of the polymer degradation. In this chapter, we have understand different types of the degradation, right? We have understand what do we mean by the random degradation and chain and degradation in the first video. That is again very important question for the GTU exams. And later we have understand thermal degradation, and we have seen the mechanism behind thermal degradation. Then we have also understand the mechanical degradation process and photo degradation, and we have also seen biodegradation of the polymers. Here we have also seen the high energy radiation degradation as well, right? So these are the different questions that can be asked for the exam. Now in the next video we will continue our subject with the new chapter. Till then, keep watching, keep learning. Thank you.